Welcome to The Explainer, where we break down complex topics by looking at the hard data. Today, we are digging into something that affects millions of people, a really common and often painful foot problem, the bunion. So here's our game plan. We're going to start with just how big this problem is. Then, we'll dive into the incredible mechanics of your foot, look at the data showing what causes the trouble, and finally, cover some solutions that are actually backed by science. Okay, first up, let's get on the same page about what we're actually talking about, and just how many people are walking around with this condition. So you might think this is a pretty rare issue, right? Well, not at all. Podiatric research shows that Hallux valgus, that's the clinical name for a bunion, affects anywhere from 2 to a whopping 15% of the US population. That is a huge range, but even on the low end, we're talking about millions and millions of people. And this picture, this shows you exactly what's going on. See that characteristic bump on the side of the foot? A lot of people think it's some kind of weird growth, but that's not it. What's really happening is the big toe is starting to deviate, to point outwards, and that forces the head of the bone behind it to stick out.
So here is the absolute key point to get. A bunion is not just a bump. It's a structural misalignment of the entire joint. The whole thing is slowly getting pushed out of whack. And understanding that it's a structural problem, well, that's going to be crucial for everything else we talk about.
All right, now to really understand what goes wrong, we first have to appreciate what goes right. Your foot is an amazing piece of natural engineering, a powerful engine for your stride.
At the very heart of how your foot works is this brilliant concept called the windlass mechanism. Think about the thick band of tissue on the bottom of your foot, the plantar fascia. It acts like a cable. Every time you lift your big toe to take a step, that cable tightens, raising your arch and turning your whole foot into a rigid, powerful lever to push you forward. It's incredible.
Here's another way to picture it. Think of your foot's arch like an architectural truss, like in a bridge. The plantar fascia is the tie rod that runs underneath, holding the whole structure together and keeping it from collapsing under the massive force of your body weight with every single step. Now, for this whole system to work at its best, there's a very specific number we need to look at. For you to get that efficient, powerful push-off, your big toe has to be able to extend upwards a remarkable 80 to 90 degrees. That full extension is what really cranks that cable tight and engages the engine. So lock that number in your head, 80 to 90 degrees. Okay, so we've got this beautifully designed system. So what throws a wrench in the works? Well, let's look at the data on the number one suspect, footwear. And right here, the data tells a very clear story. This is the core of the conflict. The average woman's forefoot is between 3¼ and 3¾ inches wide. But a typical fashion shoe, it's often designed to be no wider than 3 inches. Just think about that for a second. We are consistently forcing a wider object into a narrower container. It's a constant state of compression. And if that wasn't enough, let's add heels to the mix. This chart is just stunning. It quantifies the problem perfectly. If we start with a flat shoe as our baseline, just adding a small 3/4 inch heel increases the pressure on the forefoot by 22%. Okay, but now look what happens when you jump to a 2-inch heel. The pressure just skyrockets by 57%. All of that extra force is getting jammed directly into that narrow toe box we just talked about. And this isn't something your foot just shakes off at the end of the day. As the American Academy of Orthopedic Surgeons puts it, this sustained pressure isn't temporary. Over time, your foot literally starts to take the shape of the shoe. The shoe is physically deforming and reshaping your foot's natural structure. Okay, that's a pretty bleak picture. So what does the evidence say about how to fix this, or even better, prevent it? Let's look at the data-driven signs of a shoe that actually fits properly. Thankfully, the science on this is really clear and consistent. The solution is to pick shoes that respect how your foot is actually built. That means a toe box that's wide enough for your toes to spread out. It means keeping heels below that 2-inch mark to avoid that crazy 57% pressure spike. It means using soft, flexible materials, not rigid ones. And the classic fitting rule still holds up. You need about a thumb's worth of space at the end of the shoe. Now, wearing better shoes is a huge step. But what if you could be more proactive? Researchers have been digging into specific exercises to counteract the deformity, and the clinical data from one study is particularly revealing. Okay, so this 2025 study wanted to answer a simple question. Which exercise is actually the most effective at strengthening the abductor hallucis muscle? That's the key muscle that pulls the big toe straight. It's basically the anti-bunion muscle. And they didn't just guess. They used surface electromyography, SEMG, which means they put sensors on the skin to get precise, objective data on how much that muscle was actually firing. And the results? Well, the data was just crystal clear. Take a look at this table. All you need to focus on are the p-values. In statistics, a really low p-value means the result is significant, it's real. And look, for 3 of the 4 exercises, the p-values are high. That means no significant change. But then look at forefoot adduction. The p-values are incredibly low. This means it was the only exercise that produced a clear, measurable, statistically significant improvement in muscle activation. And the researchers' conclusion was just as direct. They basically said that, based on their data, forefoot adduction is the best exercise to get this crucial muscle working. They even recommended that it should be the starting point for any rehabilitation program. The data doesn't get much more definitive than that. So, let's put it all together. The data points to a really clear 4-step approach. Number 1, understand your foot's mechanics. Your big toe is a critical lever. 2, prioritize fit. A shoe has to fit your foot, not the other way around. 3, minimize those high heels. Remember that 57% pressure spike? And 4, if you want to strengthen your foot, the science says to focus on forefoot adduction. And that really leaves us with one final thought. Now that you've seen the hard data on width, on pressure, and on muscle activation, how is that going to change what you demand from your own footwear starting today?